Hello again, Dr. Jessica here. In this video we're going to see how we can use multiple spectra to help identify an unknown compound. For this example we're told to use the following spectra to determine the identity of an unknown compound with molecular formula C9H8O2. We can use the formula learned in Chem 2123 to help us determine the degrees of unsaturation in the molecule. So our formula for degrees of unsaturation is 2 times carbon plus 2 plus N minus H minus X all divided by 2. Now let's put the values from the molecular formula into this equation. So we have 2 times 9 plus 2 plus 0 minus 8 minus 0 all divided by 2. So when we do the math here, we end up with 6 degrees of unsaturation. Having 4 or more degrees of unsaturation is often a sign that there's an aromatic ring present. In this case, having 6 tells us that there is likely an aromatic ring and 2 additional pi bonds or rings. This will help us deciding on the structure of the unknown. Starting with the IR spectrum, we can identify that there is a carboxylic acid present by its characteristic broad, ununiform OH stretch signal ranging from 3500 to around 2500 wave numbers. A C double bond O stretch is present at 1673 wave numbers, which supports the presence of a carboxylic acid. In addition, there is a pair of signals corresponding to CC double bond stretch between 1650 and 1400 wave numbers, and a possible sp2ch stretch signal poking through the OH stretch at 3065 wave numbers. This suggests the presence of alkenes and/or aromatics in the molecule. Looking at the proton NMR spectrum, the broad singlet at approximately 11.5 ppm suggests the presence of a carboxylic acid proton. There are 7 protons worth of signals in the aromatic region, suggesting that we have an aromatic ring and something else fairly deshielded. The multiplet signal integrating for 5 suggests that we have a monosubstituted aromatic ring, as these will often appear as multiplets like this on lower resolution NMR instruments. The 2 doublets, integrating for 1 each at 7.6 and 6.5 ppm, suggest the possibility of an alkene. There are no significant peaks further shielded in the spectrum, which suggests the absence of any alkyl groups. Looking at the carbon NMR, the signal at 168 ppm supports the presence of a carboxylic acid carbon. The signals between 150 and 125 ppm are in the range for aromatic carbons. And there's a single signal at 120 ppm, which may correspond to an alkene carbon. Putting this evidence together suggests the following structure. Note, it is important to double check that the degrees of unsaturation and the molecular formula match after proposing a possible structure. There are 4 degrees of unsaturation from the benzene ring, 1 from the alkene, and 1 from the carboxylic acid pi bond. This checks out with our previously determined 6 degrees of unsaturation.